So today we're going to look at the distance formula, how to apply the distance formula to find the distance between 2 points on the coordinate plane. So here down below, they've listed out the distance formula for you. So in both cases, right, you have 2 points. One we label as x1, y1, or the x and y value of the first point, like we talked about with the midpoint formula. And then the second point is your second x and y values. So we label those as x2, y2. So here you can see in parentheses, we have x2 minus x1, so really just the difference in x values. We're going to square that, add in the difference in y values, so y2 minus y1, square it, and just be aware that when you're squaring numbers, they should always come out to be positive, right? So even if you end up with a negative value, once you subtract the x's from each other, a negative value times itself, or squared, would end up becoming a positive value, right? Like, so -3 squared, -3 times -3 should get you a positive 9. So another way to think about this is with our distance formula, just thinking it as the change in the x values, or how far apart the x values are. So the change in the x values squared, and then adding in the change in the y values squared. So here, sometimes people get confused with just the subtraction and subtracting negatives. So you can also just think about it as how far apart are the x values, how far apart are the y values. So that's going to be those values that you're going to put in the parentheses there. So we'll do a couple of these, show you examples of what it would look like. So the first one, I'm just going to go ahead and label out all the points and then just walk you through how to apply that distance formula there. So you can see it up above. So with the distance formula, first step would be to label your points. So here, one way we could do it is labeling A as our first point. So I'm going to label this A point as my x1 and y1 values. And then here for my B, that's my second point, I'm going to label that one as x2 and y2. So now as we look at the distance formula up above, now we just have to plug in these 4 values into where they need to go in our distance formula. So if we're talking about the distance of AB, we would just refer to it as AB, right? So that's just showing you the total distance between A and B, kind of like you saw earlier with our segment addition. So here under our big square root sign, here in our first set of parentheses, we're doing x2 minus x1. So copying down those values, our x2 value was an 8, and we're going to subtract out the x1 value, which is a 3. After we do that, we're going to make sure we put the squared up there outside the parentheses. Next comes our y values. We're going to start with the y2 value, which was a 2, and then subtract out the y1 value, which was a 6. And then also close the parentheses squared. So you can see where these values come from. The order does matter. It is kind of important. But really, if you accidentally subtract it the wrong way, you'll still end up squaring it. So that value will always come out to be positive. So now as we start to work our way through here, through the parentheses, simplify them down. 8 minus 3 gets us a 5. Looking at the other set of parentheses, 2 minus 6 ends up being a -4. So now we need to square these values after we've done the operations. So 5 squared, same thing as 5 times 5, gets us 25. Looking at the -4 squared, so here's where you want to make sure if you're going to put in your calculator, make sure you put the -4 in parentheses and the squared sign outside the parentheses, so the calculator doesn't lead you astray, because a negative number squared should become positive. So -4 times -4 should come out to be a positive 16. So after you square the numbers, now we can add them together. So as you add those 25 and 16 together, those add up to a total of 41. And the last step here is up above, they asked you to just round this to the nearest tenth. So now in your calculator, we're just going to take the square root of 41. So the square root of 41, you can do that in your calculator. If you have the TI-30, you're just going to get the second key, then the squared key. But the square root of 41 ends up being 6.40. So we round it to the tenths place, or just one place there. So here we get a distance of 6.4 between A and B. So that was just kind of walking you through how you could go about doing it using the distance formula. The distance formula is not something you have to memorize, and that formula is given to you. You just kind of have to know how to apply that distance formula and make sure that you are comfortable plugging in those 4 values and then following those order of operations, right? So looking at the order of operations, we did the parentheses first. So do the addition or subtraction inside the parentheses. Next, you're going to do the exponents. So taking the values that you were left with and squaring them. Remember, when you square something, it should always come out to be positive. Next is your addition. And then finally taking the square root, rounding it to the tenths place. So we're going to do it again over here with our, so looking at this second example here, Looking at R and S, right? So looking at R and S, same thing can occur. You can label the first point as x1, y1. So just make sure each point has an x and a y value. Often the mistake would be people will try to label this as like x1, x2. So no point has two x values, right? So like making sure that we don't make that mistake. Each point is an x and a y value. So there's our first x and y value. Second point S, we're going to label as our second x and y value, or x2, y2. So now as we look above, once again, right, we're going to figure out the distance of RS by plugging in those four values. So you can also think about it as you start to get the hang of this. Inside the first parentheses, really you're just trying to ask yourself how far apart are those two values, right? -4 and 2. So if that's something you can do in your head, just recognizing the difference there between those two values, that number you can just place into parentheses. But right now, I'm going to just walk you through how you would do it by plugging in and actually doing each of these operations. So we start with our x2 value. Now, here's the key. We have to subtract the x1 value. So even though the x1 value is negative, we still want to subtract a -4 squared. So now looking at the second set of parentheses, we take our y2 value, which is a -3, and then we subtract our y1 value, which is a +1. So inside the parentheses, right, is always subtraction occurring. And then in between your sets of parentheses is addition. So now, like I said, the formula will be given to you. You just have to know how to plug in these values and then simplify it. So one thing you can do here is you can enter in 2 minus -4 into your calculator, or recognize that anytime you take a 2 and subtract a -4, anytime you subtract a negative number, that is also the same thing as 2 plus 4, right? So like looking at it, 2 minus -4 really ends up giving us a value of 6. So looking at our other set of parentheses, taking a -3 and subtracting 1 is going to take us further into the negatives, and that takes us to -4. So now as we start to square these values, remember that means not multiplying by 2, but taking the number and multiplying it times itself. So 6 squared is not 6 times 2, it is 6 times 6. So 6 times 6 gets us a 36. Over here, -4 times -4, which we did earlier, ends up being +16. So as you go and square those values, remember they should always come out to be positive. Now as we add them together, 36 plus 16, that will take us to a 52. And lastly, we just want to take the square root of 52. So looking here, plugging in, taking the square root of 52, rounding to the nearest decimal, we end up with 7.21. So remember, if you're rounding, you're always going to take a look at this place here. If it is 4 or below, you're going to keep the number that was in front the same. So here, 7.21, you would keep the 2. If you ended up with something that was 5 or higher, then you would round the value before up 1 digit, right? So like here, if you ended up with 7.25, you would round it up to 7.3. But here, since we have a 1 there, rounding it to the 10th place, we end up just with 7.2. So we're gonna flip it over now. So as you look at example 2 here, they're asking you for perimeter, which is really just the distance of all the sides combined. So looking at a shape, it's the distance around the outside, right, or the distance of all your sides combined. So I'm going to plot these points. First one, A, is at 3, 7, so you're going right 3, up 7. Second one is at -2, 0, that is B. And then the last one's at 3, -4. So here we have our A, B, and C points. So we ended up with a triangle shape here, and we're trying to find the distance around the outside of that triangle. So one thing you can do here is as you plot the points and you look at the points, if you have any vertical or horizontal lines, any lines that are going directly left to right or up and down, those you can count the distance of those sides just by counting the spaces. So here, if I looked at A and C, the distance there between A and C, since they are vertical, you can just count the spaces here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So that's a distance of 11 there for that side. So that kind of saves you the hassle of having to do the distance formula. You could do the distance formula and still come up with those same values there on the same distance, but that will save you some time. That way you only have a couple sides to do the distance formula with. So we'll start with this side, AB. So if I'm looking at A and B, once again, remember you can label one of your points as x1, y1, the other one as x2, y2. And now using those points, we're going to plug it into the distance formula. So one thing you can do if you have a graph, right, is you can kind of just count the difference in your x values and then the difference in your y values. So we'll do that here just to show you how you could go about doing that. So looking at A and B, the difference in your x values would be how far apart are those points from left to right. So if I counted from A to B here, left to right, I'd have 1, 2, 3, 4, 5. So really the difference in my x values is 5, which is what we would have got, right? If you would have plugged in x2 minus x1, it would have took you to -2 minus 3, which would be -5. So here, -5, 5 is still going to get us that same answer when we square it. So next would be the change in your y values. So that could just be counted as well, looking at how far up and down the points are apart. So counting here from A to B going downwards, we have 1, 2, 3, 4, 5, 6, 7. So that would be the change in the y values there, right? So if you were to follow the formula, you could have done 0 minus 7, which would take you to -7. But you'll see here, once we square those values, it's going to give us the same. So -7 squared and 7 squared both are 49, right? Just like 5 squared and -5 squared both are 25. So really we end up with, inside here, 25 plus 49. Now we can add those values together to get a square root of 74. And then now you just want to type that into the calculator and round it to the 10th place again. So that comes out to be a distance of 8.6. So here the difference there of that side, 8.6. So now we have one more to do. We just need to find the distance here between B and C. So as we do that, now we're using B and C as the points. You can relabel the points if you want. So here, since I already have my B point labeled as x2, y2, I could make C my first point, then leave this one as the second point, or you can just completely relabel them if you would want to. So we're gonna just look at the graph again to try to figure out, remember the difference in x's, or the change in x's, goes in the first set of parentheses. The change in y's goes in the second set of parentheses. So looking at the x values from B to C, seeing how far those are apart, we have a distance of 1, 2, 3, 4, 5. So once again, 5 squared would be the difference there. You could have got that same answer right by taking your x2 minus x1. And if it came out to be -5, like I said, that's still going to be the same. So now looking at the y values, the change in the y values would be 1, 2, 3, 4. So 4 squared there, which is the difference there between 0 and -4. So as we square those, 5 times 5 is 25 again, 4 times 4 is 16 again. So 25 and 16 add up to make 41. So then you're just taking the square root of 41, which ends up giving you a 6.4. So the last step here to get your perimeter is you just want to make sure you take and add up the distance of all of these sides. So we have AB was a distance of 8.6. We're going to then add to that the distance of BC and the distance of AC to get the total distance of our perimeter here. So using our calculators, right, if we added up 8.6 plus 6.4 plus 11, that got us the total perimeter of 26. So just an example of what that would look like as you're trying to find the perimeter. Really, you can plot the points. Sometimes it's helpful to just see it on the graph. You can quickly figure out how far apart your x's and y values are. You could also do it like we did earlier in those examples. When we didn't have the graphs, you could also label your points, make one x1, y1, the second one x2, y2, and then just plug in those 4 values into the distance formula. So down here, same type of problem on example 2b. This time they're just asking you to find the perimeter of this quadrilateral, which just means you have 4 sides. So in this case, you would want to do it for all 4 sides. Like I said, if you have any vertical or horizontal sides, remember those spaces can just be counted to get you the distance there. So we're going to look here at example 3 now. So how far apart are the school and the park? So there'll be questions similar to this on the test. It says the school is located at -2, -4. So since that's the first point, I could label that one as x1, y1. Then it says the park is located at -5, 3. So I can label that one as my x2 and my y2. So once I have it labeled, remember I'm going to plug it into our distance formula, which in this case, right, we have our x2 minus x1. So in the first set of parentheses, we have our -5 minus a -2. Some people start to get like really confused or lost by accidentally like losing a negative sign there. But remember, you can always ask yourself like how far apart are these two values, right? So if you look at -2 and -5, making sure you're looking at the x values, how far apart are -2 and -5? Well, on a number line, right? If you had a number line, here we have -2, -3, -4, -5. So just like we talked about with the distance, how far apart are those two things? 1, 2, 3, right? So looking at it, if it's helpful to you, you can also just look and see how far apart are those values from each other as opposed to doing the actual subtraction. So if you were to still just follow the distance formula, filling in our next one, looking at y2 minus y1, we'd end up with a 3 minus a -4. So same thing here. If it's helpful to you, you can also just ask yourself how far apart are those things. So like from -4 to get to 0, I know is 4 spaces. And then you get from 0 to 3 is another 3 spaces. So 4 plus 3 gets me 7, right? So looking at it, now you can either do it either of those two ways, but now we can start to simplify this down. So like we said, taking a -5 and subtracting a -2, same thing as -5 plus 2, which in this case would get us a -3. So remember, we're squaring these things, so 3 would work just like -3 worked. So looking at the second set of parentheses here, taking 3 minus -4, same thing as 3 plus 4 in there. So 3 plus 4 gets us 7. So next we want to square those numbers. -3 times -3 gets me 9. 7 times 7 is 49. Adding those together, we get the square root of 58. Now to take the square root, remember it's just the second key, then the squared button usually on most calculators. So the square root of 58 ends up being a distance of 7.6. So if it says the gas station is the midpoint between the school and the park, so find the coordinates of the gas station. So this is just a midpoint question, so just a review, kind of what we talked about the other day. So midpoint's halfway between. So with that one, we want to make sure that we're going to add our two x values together first, right? And then divide by 2. And same thing with the y's, add the two y values together first, then divide by 2. So looking here, our x values were -2 and -5. We're going to add those together first, then divide by 2. So as we simplify that down up top, -2 plus 5 ends up being a -7. Dividing by 2, we can get -3.5. So as we look at our y values, here we have the y values of -4 and a +3. So add those together first. When you do, we end up with -1 divided by 2, which gets us a -0.5. So here our midpoint, where the location of the gas station would be located at that value there, x value of -3.5, y value of -0.5.